Hello, my name is Ethan Lego, and this is my video portion for my first project in EML 3701. As you can see, I already have my three flows that I used for the project, and now I'm going to create a new system and show you how I did the previous three. I'm going to make sure that this is in 2D, and I'm going to create my geometry in Design Modeler. All right, so now that we're in, I'm just gonna make sure I'm centered on the XY plane. I'm going to create a rectangle coming from the origin. And to refine the dimensions of this rectangle, I'm going to take these horizontal and vertical dimensions and define them. This should be 0.5 meters. Oh, and this should be 0.003 meters. And these dimensions line up with the ratio given in the project. It's very hard to see, but it's there. And then from here, I'm going to, I need to get this out of the way. From here, I'm going to go to modeling. Okay, so now that we've placed in our rectangle, I'm going to go to concept. I'm going to select surface from sketch, and I'm going to make sure this is box select, and I'm going to hit apply. And generate. And now we have our rectangle. And this should be enough for our geometry. And now we can go on to mesh. Here we are. Okay, so now that I'm in mesh, I'm going to make sure that all of my edges are named. This one's going to be upper plate. This one is going to be lower plate. Two sides. Um, Inlet. And outlet. All right. So now that I have all of those named, I'm going to click mesh and I'm going to hit sizing. So now I'm going to select my edges and I'm going to select my upper and lower plate. Hit apply. I'm going to use number of divisions. And I'm going to use 500, and this is because my length is half a meter, and so that means that for every millimeter, I'll have a division. I'm going to turn capture curvature off and make sure my behavior is on hard and click generate. And so now we have that mesh. We should have that mesh now. There we go. And I'm going to do the same thing for the input, the inlet and out the outlet. Apply. And here we're going to do 50 divisions. Make sure behavior is on hard and click generate. All right. So I should have my mesh. However, on the ends, it gets a little bit wonky. So what I'm going to do for that is I could get this. Nope, that's not right. There you go. I'm going to select um, face meshing and select that face, hit apply, hit generate. And so now I should have a very detailed mesh. And that should finish the meshing. Okay. Now I'll be going to set up. Selecting double precision and multiple processors. Okay, so now that my mesh has fully loaded in, I'm going to make sure that my model is laminar, not viscous. And because I am using water instead of air, I need to make sure that I'm using water and not air. So I'm going to click New Fluid, go to the Fluent database all the way down to get water liquid. Copying that and closing. And to make sure, to double check that my system is going to be using water, I'm going to go to cell zone conditions, and under fluid, I'm going to select water liquid. And that should have updated. So now I can actually delete air just to validate that it will always use water. And so now I'm going to edit my boundary conditions, making sure that my inlet is velocity inlet. And I'm going to start with a velocity magnitude of 0.5 meters per second. I'm going to make sure that at the outlet, I have no reverse flow. And I'm just going to double check that the plates are non-moving. Yeah, stationary. All right, and I'll go to reference values. Make sure that I'm computing from the inlet. These values seem to be correct for water. Making sure the reference zone is body, surface body. And that should be everything. I'm going to hit initialize. And then it'll go through around 10. And it says it's done. Now I'm going to go to calculation, run calculation. And I'm going to set the number of iterations to 500 and click calculate. All right, so it says it's done. So I'm just gonna double check that it looks correct by placing in vectors. These will be velocity vectors. Going to save that and compute and close. And so we can see that it does appear to be working. All right, so that's it for setup. And so now I can go to results. All right. So here in results, I'm going to want to place some reference lines, including midpoints, which for my 1/2 meter plates, I'm going to use 0.25. And for the height, I set at this number. I'm going to use 100 samples. And there we have the line. And I'm going to repeat this for the endpoint. I'm going to go a little short. Um, okay, that should have done that. Just going to double check that. Hello. There we go. Yep, okay. And I will also be adding lines for the flow near the inlet. And I'm just going to make that um, like here. Making sure I do my height. As well as at the inlet. Should be correct. Just gonna double check. Yep, looks good. All right, so those are all of my lines that I'm going to do. Now I'm going to insert my velocity vectors. I'm going to make sure I use symmetry. I'll use line arrowheads. I'm going to make this very, very small. And it generates the legend. I'm also going to edit this legend, make it horizontal, and use fixed notation. And so if I zoom in here, you can see all of the arrows and the velocity gradient. Just going to make these slightly smaller. Let's do a little too small. Seems like 3 is probably just about correct. Okay, there we go. So there you can see the velocity vectors. And I will also add in contours. Making sure that I'm at symmetry, and I'm using velocity U, and I'm going to use 100 contours. And there we go. Here is that contour. And now I'm going to go over to charts to plot the velocity velocity plate lines. Um, oh, the velocity profiles. Excuse me. And here I'm going to type in midpoint, endpoint, near, inlets, and at inlet. Okay. And making sure to select the correct locations. Also selecting the correct axes. All right. Don't know what that was, but here we are. As you can see, um, I have all of these, the velocity measured at each of these points along the two plates. Um, Near the inlet and at the inlet, you can see starts out with a more uniform velocity um, as yeah, compared to the height. And by the time it reaches the midpoint, it has pretty much reached its final profile. Just a little bit of difference. And so now, that's pretty much it for the I don't know how to pronounce that one, Proswell flow. For Couette flow, the only difference is um, when you're in the CFD builder for the upper plate, you select a you you make it not stationary and you give it a velocity, which should come up right here. Yeah, you select moving wall, but I'm not going to do that right now. And then you go through the process again, and you can select any velocity for that moving wall, as long as it stays with the correct Reynolds number. And then for hybrid flow, you just combined the previous two. And yeah, that should be everything.